Hi everyone, welcome back to our channel. In this video, I will revise the concepts of gradient. Already we discussed the definition of gradient in earlier videos and we did some problems on that videos. In this video, once again I will revise some more topics on this one. So according to the definition of gradient, if phi is a scalar point function, then gradient phi is represented by grad phi. Sometimes it is also represented by del phi, don't forget it. This is symbolic form. The definition of this one is I bar into dou phi by dou x plus j bar into dou phi by dou y plus k bar into dou phi by dou z. Here the product between I bar and partial differentiation of phi is nothing but scalar product. So this is also represented by summation of the first term sigma I bar into dou phi by dou x. So mainly gradient has three applications. Very first application is to find unit normal vector. To find unit normal vector. So this is the major application of gradient. Suppose we have a surface and the equation of surface is in terms of xyz. Then we can easily find out the normal vector to the surface at the given point by finding gradient. So normal vector to the given surface is nothing but del phi. Gradient gives the normal vector. After getting normal vector, what is the unit vector? You know it. N bar by its length. That is del phi by its magnitude. Okay, this is very important application. And the second one is gradient is used to find the angle between two surfaces which are intersects at the given point. Suppose assume that two surfaces are intersects at any point. Okay, so the angle between two surfaces at the intersecting point is nothing but angle between the two normals. If we can take, this is the first normal n1 bar, this is the second normal n2 bar. If theta is the angle between the two normals, then the formula for cos theta is equal to n1 bar dot n2 bar by length of n1 bar into length of n2 bar. Okay, suppose these two normals are perpendicular, it means that both surfaces are intersects orthogonally, then theta becomes 90 degrees. In the case of both surfaces are intersects at right angle, then theta becomes 90 degrees. So cos 90 is 0 and you can take this denominator to this side, you will get n1 bar dot n2 bar is equal to 0. This is the condition for orthogonality of two surfaces. And one more application and important application is to get the directional derivative of a scalar point function. Already we discussed this topic in earlier videos. Directional derivative of a scalar point function phi in the given direction is E bar dot grad phi, otherwise del phi. This is dot product. Here E bar is the unit vector of the given direction A bar. So it can be obtained by A bar by length of A bar. Already we discussed some problems. However, in this video I will give some examples on each application here. Okay, which are very important, and surely you will get good marks if you listen entire video. Okay, see the problem. Find the unit normal vector to the surface x square y plus 2xz is equal to 4. Some surface is given to you, you have to find out unit normal vector at this point. This point is lie on this surface. Okay, maybe the surface is in this form. Okay, no, it is not necessary to get the exact shape of that surface. So this point is 2 minus 2 3. First we have to find out normal. Okay, actually normal is nothing but like this. This is the normal to the given surface which is represented by n bar. So how can we find out the normal? By finding the gradient. Gradient gives the normal. So first write the given equation of the surface as 5 you can represent with 5. So you will get x square y plus 2xz minus 4 is equal to 0. So normal to phi is del phi is equal to, write the formula for del phi, nothing but grad phi, dou phi by dou x plus j bar into dou phi by dou y plus k bar into dou phi by dou z. Very simple problem this one is. So what is the partial differentiation of this phi with respect to x? In this case, except x remaining are all constants. So partial derivative of x square y with respect to x is, just write the derivative for x square. It would be 2xy plus partial derivative of 2xz is 2z into I bar plus j bar into, this time you can take the partial derivative with respect to y. In this case, except y remaining are all constants. So partial derivative of phi is only 1, x square into 1 is x square. This term becomes 0 plus k bar into partial differentiation of phi with respect to z. This is 0, this is only 2x. Now substitute the point in this one. At the point 2 comma minus 2 comma 3, what is del phi? X value is 2, y value is minus 2, z value is 3. So 2 into 2, what is y value? Y value is also minus 2 plus 2 into 3 into I bar plus j bar into x is 2 square, it is 4 plus k bar into 2 into 2, it is 4. So however, this is 2 2s are 4 minus 8 plus 6, it would be minus 2, minus 2i bar plus 4j bar plus 4k bar. This is the normal vector to the given surface phi at the point 2 minus 2 3. We need unit vector for this one. So required unit normal vector is, it is represented by e bar. You can take this one is n bar. So you will get n bar by length of n bar. Normal vector is represented by n bar. So minus 2i bar plus 4j bar plus 4k bar. How can we find out the length, otherwise magnitude of this vector? Already I discussed earlier videos how to get length. Root over sum of squares of components. Minus 2 square, it would be 4. 4 square, 16. Again it is 16. So 16 plus 16, 32. 32 plus 4, 36. Root over 36 is nothing but 6. So 1 by 6 into minus 2i bar plus 4j bar plus 4k bar. So 2 is the common term. So 1 by 3 gets cancelled. 3 times gets cancelled in the denominator. So you will get minus 2i bar, sorry, 2 gone outside. So minus I bar plus 2j bar plus 2k bar. In this way, you can easily get the unit normal vector to the given surface. Okay. Now gradient gives the normal to the given surface. One more practice problem is here. Find the unit normal vector to the surface z is equal to x square plus y square at the point minus 1 minus 2 5, which is also very important problem. You can try this one, and if it possible you can comment the answer in my chat box. See the next example. The second application of the gradient is to find the angle between the two surfaces. See the example on this one. This is also very important. Find the angle between two surfaces x square plus y square plus z square is equal to 9 and z is equal to x square plus y square minus 3 at the point 2 minus 1 2. Okay, this is the surface phi 1. Assume that this is phi 1. This is the another surface phi 2. This both surfaces are intersects at the point. Maybe it intersects at 2 points, but he provided only one intersect point. It is 2 minus 1 2. So we have to find out the angle between here. So the angle between the two surfaces is nothing but angle between the two normals which are drawn to given surfaces. If you draw this here normal, here it is n1 bar. If you draw a normal here, it is n2 bar. We have to find out the angle between them. What is the angle between them? If theta is the angle between between the both normals, then cos theta is equal to n1 bar dot n2 bar by length of n1 bar into length of n2 bar. So first of all we have to find out the normals of both surfaces. Let phi 1 is equal to x square plus y square plus z square. Take this 9 to left side, you will get minus 9 is equal to 0. And I will write the second surface here, which is x square plus y square. Take this z to right side, you will get minus z minus 3 is equal to 0. This is 2 and this is equation number 1. So first find out normal. Normal to phi 1 is n1 bar is equal to del phi 1. Already I discussed in earlier problem. In previous problem, del phi 1 gives the normal to phi 1. It would be I bar into dou phi by dou x plus j bar into dou phi by dou y plus k bar into dou phi by dou z. So for vector differential operators, students should have the knowledge on partial differentiations. Whenever we are taking the partial derivative with respect to x, except x remaining are all constants. So I bar into 2x, remaining are all constants. Their partial derivatives with respect to x is 0. That's why first term is 2x I bar. Next we are taking the partial derivative of y 1 with respect to y. This case just write the partial derivative of y square, remaining are all becomes 0. So 2y j bar. Similarly 2z k bar is next term. And replace the point because this point lies on this normal. At 2 minus 1 2, n1 bar becomes, replace x is equal to and y is equal to minus 1, z is equal to 2 2s are 4i bar, 2 into minus 1 minus 2j bar, 2 2s are 4k bar. Now come to here, again normal to the second surface. Phi 2 is del phi 2. Already formulas here, you have to replace phi 2 instead of phi 1 in the formula. So I bar into partial derivative of this term, it would be only 2x plus j bar into 2y plus k bar into partial differentiation of phi 2 with respect to z is minus 1. Okay. At the point 2 minus 1 t, 2 minus 1 2, this point lies on both normals. That's why we have to replace this point on both normals. So you will get del phi 2 is equal to 2 2s are 4i bar, replace y is equal to minus 1, so you will get minus 2j bar and there is no z coordinate, so plus into minus minus k bar. This is n2 bar. Okay. If theta is the, write the formula first. If theta is the angle between the two normals, angle between the two normals, then what is the formula for cos theta? Then cos theta is equal to n1 bar dot n2 bar by length of n1 bar into length of n2 bar. Okay. So how can we find out the dot product? So multiply the corresponding components and add them. We have to multiply I bar coefficient to I bar coefficient. 4 4s are 16. J bar coefficient into J bar coefficient. Minus 2 into minus 2. It would be plus 4. 4 times of minus 1. Minus 4 by length of each unit vector. 4 square. 16 plus 4 plus 16 into root over here 4 square. 16 minus 2 square. It would be 4. Minus 1 whole square. It would be 1. So plus 4 minus 4 gets cancelled. 16 by, this is root 36. So it is 6 into root 21. So 2 table gets cancelled. 8 by 3. So theta becomes cos inverse of 8 by 3 root 21. This is the angle between both surfaces. Suppose if anyone take the phi 2 as z minus, here actually given surface is given as z is equal to x square plus y square minus 3 is equal to 0. I am taking this z to this side. If anyone take x square plus y square minus 3 to left side, you will get negative sign here in the angle. Okay, no problem, you can do any one. Okay, this is the procedure to get the angle between two surfaces. Don't forget it. So this is the another example. Find the values of a and b. Find the values of a and b so that the surfaces ax square minus byz is equal to a plus 2 into x and 4x square y plus z cube is equal to 4. This is one surface, this is another surface. May intersects orthogonally. Orthogonally means they were intersects at perpendicular, otherwise at right angle at the point 1, minus 1, 2. This point lies on both points. Don't forget it. So here already angle between the two surfaces provided you as 90 degrees. By using that condition, you should find out the a value and b value which are unknowns involved in the equation of the surface. This one is also very important one. So listen carefully. So first write the given equation of the surface. Surface is phi 1 is equal to ax square minus byz. You can take this right side term to left side. You will get minus of a plus 2 into x. Take it equation number 1. Now find out normal. Normal to phi 1 is n1 bar is equal to del phi 1. If you find out the gradient to the surface, it gives the normal. Okay, first of all we have to find out the normals to the both surfaces at the given point. After that we can use the perpendicularity condition. So I bar into dou phi 1 by dou x plus j bar into dou phi 1 by dou y plus k bar into dou phi 1 by dou z. So what is the partial differentiation of phi 1 with respect to x? I bar into, it is 2x. 2x into a. So 2ax minus, this becomes 0. Derivative of x with respect to x is 1. So you will get minus a minus 2, which is the coefficient of I bar, plus j bar into, now this time we have to take the partial derivative with respect to y. In this case, except y remaining are all constant. So first term and last term becomes 0. Derivative of byz with respect to y is minus bz plus k bar into, this time we have to take the partial derivative with respect to z. So first term and last term becomes 0. You will get minus by only. So replace the point at 1, given point is 1 minus 1 2. n1 bar becomes x coordinate is 1, y coordinate is minus 1, z coordinate is 2. So I bar into x value is 1. So you will get 2a minus 2 plus plus into minus minus and z is 2. So you will get 2b into j bar and y value is minus 1. So minus b into minus 1 plus bk bar. Okay, please highlight with your box. Now what is the equation of other surface? Equation of other surface is given as phi 2. So it would be 4x square y plus z cube is equal to 4. Is equal to 4 can be written as minus 4 is equal to 0. Take it equation number 2. So first find out normal to phi 2. Normal line to the surface phi 2 is nothing but n2 bar, which is nothing but del phi 2. Already we wrote the formula of gradient here. It is not necessary to write again and again the same solution. So n2 bar is equal to I bar into dou phi by dou x. So it means just take the derivative of x square with respect to x. It would be 2x. 2x into 4 is 8xy. Remaining are all constants whose derivatives becomes 0 plus j bar into dou phi 2 by dou y. So 4x square is only term plus k bar into partial derivative of phi 2 with respect to z. So first term becomes 0, last term becomes 0. Derivative of z cube with respect to z is 3z square. Replace the point again at the point 1 minus 1 2. So replace x value is 1, y value is minus 1, z value is 2. You will get n2 bar is equal to 8 into 1 into minus 1. So you will get minus 8i bar. Minus 8i bar. X value is 1. So you will get 4j bar. Z is nothing but 2. 2 square is 4. 4 3s are 12k bar. Okay, so we are writing equations of both surfaces and we are getting the normals of both surfaces, which are represented by n1 bar and n2 bar. Since 1 and 2 intersects orthogonally, we get what is the perpendicularity condition? What is the perpendicularity condition? Dot product of both normals should be 0. n1 bar dot n2 bar is equal to 0. So what is the dot product? In both vector point functions, multiply the corresponding components and add them. So multiply I bar coefficient and I bar coefficient, multiply j bar coefficient, multiply k bar coefficient, k bar coefficient, and you can add all terms. So you will get minus 8 into, actually here you can easily write this I bar 2a minus a, it would be a minus 2 minus 2bj bar plus bk bar. You can note down this a minus 2 into minus 8. So minus 8 times of a minus 2 and 4 times of minus 2b, it would be minus 8b, 12 times of b, 12b is equal to 0. So minus 8a minus of minus plus 16 minus 8b plus 12b, it would be 4b is equal to 0. 4 gets cancelled. Minus 2a plus 4 plus b is equal to 0. So how can we write this one? Minus 2a plus b is equal to minus 4. We have only one equation in terms of a and b, but we need two equations in terms of a and b to solve a value and b value. Okay, see here, we are observing that since given point 1 minus 1 2, here point 1 minus 1 2 is lies on surface 1, it satisfies equation 1. So a into 1 square, so it is a, and b into y into z. Y value is minus 1, z value is 2, so you will get minus into minus plus 2b, and here x is minus 1, x is 1, so you will get minus a and minus 2 is equal to 0. This point should satisfy the equation number 1. Okay, so minus a plus a gets cancelled, 2b is equal to 2 and b is equal to 1. B value is 1. So replace b value in equation number 3. What is the equation number 3? Minus 2a plus b. So minus 2a plus b value is 1 is equal to minus 4. So minus 2a is equal to minus 4 minus 1 minus 5, and a value is 5 by 2. In this way we can get both values of a and b. B value is 1 and a value is 5 by 2. For these values only, given two surfaces intersects orthogonally. See the next problem. Find the directional derivative of phi is equal to x square yz plus 4xz square at the point 1 minus 2 1 in the direction of the vector 2i bar minus a bar plus 2k bar. Already we discussed this type of problems in earlier. Once again I will revise one more problem on directional derivative. See here, first write the given scalar point function. Given phi is equal to x square yz plus 4xz square. So what is the formula for directional derivative? Directional derivative is e bar dot grad phi. Okay, so whenever we are going to find out directional derivative of a scalar function, immediately find out gradient phi. It is the first part. So grad phi is equal to I bar into, every problem is depends upon formula only. If you get the knowledge and grip on the formula, you can easily complete any problem in vector differential operators. So I bar into only partial derivative of y with respect to x. So 2xyz plus derivative of x with respect to x is 1. So 4 into 1 into z square, it would be 4z square plus j bar into this time y. So x square z plus 0. This term does not contains any y. That's why entire term becomes constant whose partial derivative with respect to y is 0. Plus k bar into this time with respect to z, only z is the variable. X square y plus 2z into 4x, 8xz. So students have to do the partial derivatives without any mistake. If you get any mistake, you didn't get the much marks. At the point, we have to find out the direction derivative at the given point. So at a given point P, 1 minus 2, 1, above gradient becomes, replace x value is 1 and y value is 2 and z value is 1. Here 2 into x value is 1, y value is 2. 2 2s are minus 4, I bar into minus 4 and z is 1. So plus 4. Minus 4 plus 4 gets cancelled. J bar into x square z. Z is 1 and x is also 1. So it is 1. Plus k bar into x square y. Y is minus 2. So you will get minus 2. Z is 1, x is 1. So you will get 8. So 4 minus 4 gets cancelled. It is j bar. It is plus 6k bar. So this is the gradient phi. We are going to substitute this value in this formula at final. Now we have to find out E bar. Here a direction is given to you. In which direction we are going to find out the direction derivative? You can represent this given direction with A bar. So given direction is A bar is equal to 2I bar minus J bar plus 2K bar. Very simple model this one also. So E bar is equal to unit vector along A bar. A bar by, suppose we are going to find out unit vector of anything. How can we find out? That vector by its length gives the unit vector. E bar is the standard notation of unit vector. Don't forget it. So 2I bar minus J bar plus 2K bar whole by root over 2 square. 2 square means 4 and minus 1 whole square plus 1 and 2 square is again 4. So 4 plus 4, 8, 8 plus 1, 9. It would be 1 by 3 into 2I bar minus J bar plus 2K bar. So substitute these all values in this formula. We know that. Write the formula of directional derivative of a scalar function. So write E bar first. It would be 1 by 3 into 2I bar minus J bar plus 2K bar dot gradient phi. It would be J bar plus 6K bar. Okay, from your intermediate knowledge, otherwise 11th grade and 12th grade, every student have the knowledge on finding dot product and cross product of two vectors. So how can we get the dot product? Multiply the corresponding components. There is no coefficient of I bar. So 2 times of 0, 0 minus 1 into J bar coefficient. It is minus 1 K bar coefficient, K bar coefficient. It would be 2 6 are 12. So 12 minus 11, 12 minus 1, it would be 11, 11 by 3. This is the directional derivative. Directional derivative is nothing but a constant, nothing but scalar. Don't forget it. This is also very, very important one. And move to the next one. See, sometimes problems on position vector is given to you and he asked what is the gradient of that function which is in terms of r. Prove that del of r power n. Del of r power n is also known as gradient of r power n because r power n is the scalar. If you are applying delta to a scalar, it becomes gradient. The result should be n into r power n minus 2 into r bar. Everybody knows that r bar is the universal notation of the position vector which is expressed as xi bar plus yj bar plus zk bar. This is also very simple one. See, we know that what is r bar? Xi bar plus yj bar plus zk bar. I will take this one as sigma summation of xi bar which is first term. So what is small r? Small r is nothing but magnitude of the r bar. So how can we express the magnitude? Sum of squares of components. X square plus y square plus z square. Take it equation number 2. Okay. Squaring on both sides. You will get r square and here square root gets cancelled. So you will get x square plus y square plus z square. You can give equation number to this one. Take partial derivative with respect to x. Partial derivative with respect to x. So you will get 2r into dou r by dou x. R is not a constant. R is a variable in terms of x, y, z. That's why partial derivative is 2r into dou r by dou x. Here only 2x. So 2 gets cancelled. From this, dou r by dou x is equal to x by r. I am taking this r to right side denominator because it is in the product. Similarly, we can get dou r by dou y is equal to y by r, and dou r by dou z is equal to z by r. Okay, whenever position vector r bar, otherwise its magnitude, is involved in the statement of the problem, these were the common steps for everything. Okay, now we are going to find out the gradient of r power n. By the definition of the gradient, what is grad phi? I bar into dou phi by dou x plus j bar into dou phi by dou y plus k bar into dou phi by dou z. I will write the short form using the summation notation of the first term. In the similar way, what is gradient of r power n? Here we have r power n instead of phi. So summation of replace phi is equal to r power n. Summation I bar into dou by dou x of r power n. Summation I bar into, what is the partial derivative of r power n? It is in the form of x power n. So n into r power n minus 1 into, again internal derivative is dou r by dou x. Don't forget to write the partial derivative of r with respect to x internally in the product. We are observing that n is the constant term. So write outside from the sigma. Sigma I bar into r power n minus 1 into, what is dou r by dou x? Here we got it in the earlier. We got dou r by dou x as x by r. So this can be written as n into r power n minus 2. If you take this denominator to numerator, it becomes r power n minus 2, which is also constant term. So summation is depends upon I bar and x variable only. Remaining are all constants. Sigma xi bar. So what is the sigma xi bar? Summation of xi bar is nothing but r bar. So n into r power n minus 2 into r bar. So finally you are getting that del of r power n is equal to n into r power n minus 2 into r bar. In this way we can prove the result. Okay, in the similar way you can try the problem del of f of r, which is also very important repeated problem. Please mention the answer in chat box. If you do not get it, please send a WhatsApp message to me. I will send the solution of this one. Thank you very much.